the standard normal distribution. Example 2. So this time we have an unknown standard deviation and variance. Once again we're given a probability, and we can't solve this problem using this normal distribution from the calculator because we don't have the standard deviation. So we'll go through the standardizing process again, and the probability given tells us to shade to the left an area of 0.2119. I've done that. 46, the mean, which is 50 there. So that's the distribution of x, the original distribution. Now moving on to the standard normal distribution, which is what we're going to use to solve the problem with, we need to work out the z value here using this probability. So menu option 7, inverse normal, option 3. The cumulative area to the left of our line here is 0.2119. The standard deviation and mean already in there for the standard normal distribution. So we get this z value, and it's negative as expected. For z, the mean is 0. We have negative z values on this side, positive z values on this side. So this value is for z. It's this in the formula. So z is equal to x, which is 46, minus the mean, which is 50, divided by the standard deviation, which is unknown. Once again, for the standardizing formula, everything on the right hand side comes from the distribution of x. So we're using the 46, we're using the 50, we're using this unknown standard deviation on this side. Anything on the left hand side is from the standard normal distribution, and this value here was our z value there, like so. Now we need to rearrange to work out the standard deviation. So our standard deviation is 5.00 to 3 significant figures. Example 3. This time both the mean and the standard deviation and variance is unknown, but we're given two probabilities. So we set up two standardizing equations and solve them both simultaneously at the end to work out our two unknowns. Two equations, two unknowns, simultaneous equations. So for the first probability, we're shading to the left this area. So I've drawn my line, I've marked in my probability, and now we have to work out the unknown z value here. So from the calculator, we input the area. That's the cumulative area to the left of this line, 0.1469. The standard deviation is 1, the mean is 0, and this is all for the standard normal variable z. And the calculator will give us this value, which is for z here. So now we have to use the standardizing formula, so inputting all the values that we have. So once again, for the standardizing formula, the right hand side here has all values from the original normal distribution, that would be x, and the left hand side is for the standard normal distribution, z. So if I rearrange my terms into this order, and there's a reason for doing this, I've got my two unknowns on the left hand side and equal to any constants on the right hand side. This will help with the solution to the simultaneous equations later. So moving on to the second probability that's given, so we're shading to the right an area of 0.025, and the cumulative probability up to this line would be 1 minus 0.025, which is 0.975. And then again we can put the values into the calculator. So I've put in the 0.975 as the area, the cumulative area, and these again are values for the standard normal distribution, and the calculator returns a z value of 1.96 rounded, like so. And then using the formula again, on the left hand side we've got z, and that's equal to the x value, which in this case is 35 there, minus the mean divided by the standard deviation. And I'm going to rearrange the equation into this form, again I've got my unknowns on the left hand side and any constants on the right hand side. So we have simultaneous equations to solve, and look at the order of the terms. I've got the mean, then I've got the standard deviation, equals, and then constants. Okay, so if your equations are in this order, then on the calculator, so menu, the shortcut is option A, but it's this one here, simultaneous, option 1. We have two unknowns, so we put in the coefficients for all of these terms. So the coefficient of the first term is 1, for the second term it's minus 1.0498, and then 15 on the other side, and again the coefficient here is 1, and for this term it's 1.96, and then 35. And when we press equals, now this value represents the unknown that was on the left hand side here, so that's the mean. And pressing equals again, the second value represents the unknown here, so 6.64 is the standard deviation. So to three significant figures, the mean and the standard deviation, and these were the displays on the calculator. For practice, try these questions.